Generally, in any entity type, we are going to have lots of entities. For example, if you take any entity type like employee, you are going to have many employees, right? Now, the question arises, how can we distinguish one employee among all these employees, right? Just to answer that, just to have a uniqueness constraint, what we are doing is, let us say we have this entity type, and entity type is employee, okay, and in this employee entity type we are going to have many employees, right? Now we have to identify each one uniquely, which means we are going to have some information about every employee, right? So every information is going to be attributes. So just to identify one of them uniquely, we are going to have some special attributes which are called as key attributes. For example, employee number. If you look at employee number is going to be unique. Or maybe if you take a student ID is going to be unique. There has to be something in the entity, the attribute, at least some attribute which is going to uniquely identify that particular entity. So that uniqueness, this is also called as uniqueness constraint. And along with other constraints like structural constraints, this uniqueness constraint is going to be implemented using the key attributes. Now, how do we decide which one is going to be the key attribute? Again, from the requirement analysis. Whenever you talk to the users, they are going to say that, see, we have these many employees, and out of all these employees, we are going to give them some identity cards, and every identity card is going to uniquely have a number which is going to identify them. So depending on that, we'll set one of the attribute as the key attribute. Now, once we fix that attribute, then what happens is, whenever you try to insert any new element, we will always check that the new element which is going to be inserted, which means the new entity, should always have a different value in that key attribute, right? So for example, for this employee, maybe you can have an attribute employee ID, right? Sometimes what happens is, more than one attribute might qualify to become a key attribute. For example, if you have a car, it will have one is registration number and other is engine number. Engine number is given by the manufacturer to identify that engine uniquely, and every car is going to get a unique engine number. And similarly, registration number is given by the government, and it is also going to be unique, right? And sometimes we might have more than one attribute which is going to be qualified as a key attribute. In that case, as the schema designer, as the database designer, you have the liberty to choose any one of them to go for the key attribute. Sometimes what happens is, we might not have any key attribute at all. That is where we face some problems. Some entities might not have any key attribute. For example, let us say there is an employee and his family, the family of his dependents. So all these dependents are going to depend on this employee. Now in that case, when these many people are depending on him, we cannot give employee ID to all these dependents also, right? For example, you have a family of 5 members, and in your database or in your company's database, they are all going to save they are going to save the information about your dependents also. Now they cannot give the employee IDs to the dependents also, right? Then that particular employee, the dependent set, see this, what I mean to say is, let us say there is employee set, employee entity set, okay, and now there is dependents, okay. Now the problem is, there will be at least one attribute in the employee, especially that employee ID, which is going to uniquely identify one entity in this employee type, right? But then here in this dependent type, we might not have any such number. What we have is generally name, age and relationship. Let us say name is A, right, and age is 25, and relationship is, let us say, son or something like this, son of an employee, right? And at some other point there might be some name A which is same as this, and there might be some person who is of exactly same age and who is also a son of some employee, right? Now these two entities cannot be distinguished uniquely. That is the problem. So just to overcome such problems, so whenever any entity is not having this key attribute, then such an entity is called as weak entity, okay. And if a entity is having this key attribute, then such an entity is called as strong entity. Okay, and just to overcome this problem of uniqueness, what rule we apply is every weak entity has to be related to a strong entity through a relationship. Okay, and what should this relationship be? It is called as identifying relationship. So it is a special type of relationship which is used for identifying a weak entity, right? So this is not the normal relationship which we have been talking about. Other relationships are not necessary, they are not mandatory, they are optional, but here this relationship is mandatory. Without this relationship, there cannot be any entity existing here. It is called as existence, right? So for every dependent here, there has to be an employee here, but for an employee here, he might not have any dependents. That is not the real world scenario, but then there might be a case, a person might not be having any family, right? So that is not really the case, but then there might, you can even allow some employees to not have any dependents. Are you understanding this? Okay, don't think how it is possible, let's assume that it is possible. Okay, so what I'm trying to say is, if there is an dependent, then definitely there will be an employee on whom he is depending on, otherwise he will never enter our database of the company, right? And in case there might be some employee for whom there may be no dependent at all. Now how do we represent it? See, this is called as strong entity. Any entity which is having primary attribute is called as strong entity, and any entity which is not having primary key attribute is called as weak entity, right? So what is key attribute? It is used to identify entity uniquely, that is uniqueness constraint. Now how to represent this in terms of ER diagram is, we know that we are going to use a rectangular blocks in order to represent an entity type, and now generally we use this diamond in order to represent a relationship, and since it is an identifying relationship, we are going to use double diamond like this. So every identifying relationship we are going to use this double diamond, right? And every weak entity we are going to use this double rectangle. Okay, now this is the strong entity like employee, for example. This is the weak entity like dependent, and this is the identifying relationship like depends on. Okay, like depends or depends on, which means this particular dependent depends on this particular employee. What about the participation? The participation is always, it should hold true, always the participation of weak entity in identifying relationship has to be total. Very important point. Okay, what I'm trying to say is, whatever you think about here, see, whoever is dependent, he should always be participating in a relationship, which means he should always depend on someone here, right? So remember this, always the participation of weak entity in a identifying relationship is total, which means if you watch it like this, right, if this is the weak entity, then every entity should have some participation in the relationship, right? Okay, and what about the other one? The strong entity need not be total. That is what I'm saying. So because they really don't need them, but they really don't need them, they are dependents, they have to depend on this, right? And there are various names for this also. Now this entity is called as owning entity of this one, or this entity is said to be owned by this one. Owned means you understood this, right? Owned, the actual meaning of owned, which means without this it cannot exist, right? So if you want to add anyone into this, they should definitely depend on this. Why is this so? Is the only way we could actually identify them is by taking the key attribute from here and adding to this. See, now dependent is going to have name, right? Just assume that dependent is going to have name, and maybe he is going to have some age, and maybe he is going to have some relation. right? Relation with some employee. Now along with these, if we add the key attribute of this strong entity, let us say employee is going to have employee ID. Now using all this, we can identify one entity in this weak entity uniquely. So sometimes what happens is we may not be able to identify like this. We may not be able to identify an entity uniquely by using one attribute. Then what we do is we take more than one attribute to uniquely identify it, right? So which means we can combine some of the attributes to make it a composite attribute, and maybe we can use that to identify it. For example, let's say we have this car, right? And car is going to have, one is let us say state, and other is registration number within that state. Okay, generally if you look at your vehicle numbers here in India, you will see something like this: KA04, right? 1234, something like this. What does it mean? KA means the state is KA, maybe 04 means maybe Bangalore, and 1234 means the registration. Now what happens is either this state or this registration number within this state might not be able to identify a car uniquely, isn't it? But then when I combine these two, which means if I write this entire number, I'll be able to uniquely identify it. Sometimes what happens is if an attribute individually is not able to act as a key attribute, or if it is not able to uniquely identify a entity, then what we try to do is we try to add many attributes to make it a composite attribute, and we call that composite attribute itself as the key attribute. That can happen, but then you should see that whatever composite attribute you are trying to form should be as minimal as possible, which means if this itself is going to act as a composite attribute, which is going to be the key attribute, then don't add anything to this, right? So whenever you try to add many attributes in order to make a key attribute, in order to uniquely identify an entity, see that it is as minimal as possible, which means if one, or let us say if these two attributes are going to be act as a key attribute, then don't try to add one more attribute to this and again say that it is also a key attribute. Okay, when you are trying to combine them, see that we need only as minimal as required. Okay, similarly what we are actually doing in this case is, in case of weak entities, we are going to take some of the attributes from the weak entities, and to this weak entity we are going to add some attributes from the strong entity, and we call the entire combination as the key for the weak entity. Got it? But then one thing is for sure, if an entity is weak entity, then its participation is total, but then every total participation might not mean that it is weak entity. Okay, I'll tell you what I mean by that. See, I'm saying that if an entity is weak entity, then it should definitely be in total participation in the identifier relationship, like this, right? Which means without a dependency on the strong entity, there will not exist any weak entity. Okay, but then if there is total participation, it need not mean that the entity is weak. So example is, let us say there is employee and works for relationship. There is employee entity and works for relationship, and employee works for a department, right? And we know that every employee will work definitely for one department, therefore the participation of employee is total. But then you should not derive that since completely they are depending on this, which means totally they are participating in the relationship, employee must be weak. No, employee will be strong, right? See, actually without depending on a department, no employee should exist, that is for sure. What is the constraint? We already said that every employee should work for at least one department. Therefore, if an employee is not working for some department, he will never exist. That is fine. But then it doesn't make employee a weak entity. Got it? So total participation doesn't make a entity weak, but then if an entity is weak, it will definitely participate totally. That is what the meaning is, right? It is very important point. People will get generally confused in classrooms. What I mean to say is, see, if it is weak entity, it has to have total participation, right? But if you are having a total participation, it doesn't necessarily mean that the entity is weak. Okay, I'll give you one more example. It might help you in understanding this concept. Let us say a person is having a license card. Okay, that you have the license cards, right? The driving license, DL. Now that driving license will never exist without a person, isn't it? If there is a driving license, there will definitely be a person, right? Okay, alive or dead, that is secondary. If there is a driving license, there will definitely be a person, but it doesn't make that driving license a weak entity. Okay, what I mean to say is, let us say it is license card entity, that your DL, right? And now it is person entity, right? And this is hold, right, holding. So license card is being held by some person, right? Therefore, what about the participation? You can say that it is totally participating and it is partially participating, which means there might be some people who doesn't have driving license, but then if there is a license card, if there is a DL, definitely there will be a person who is going to hold it, isn't it? So what does it make? The participation of license card in this relationship is total, right? But then you should not think that this license card, that particular entity, is weak, because license card is going to have a unique number on it. Let us say license number. That license number itself is going to identify this uniquely. Therefore, license card is definitely going to have a key attribute, right? And that key attribute is license number. So since license card is going to have license number, right, and it is going to act as a key attribute for this, it is also a strong entity. So by participation, don't derive the either it is weak or strong. So either weak or strong, that depends on whether it is having a key attribute or not. If it has a key attribute, strong. No key attribute, weak. Then what we do? Identifying relationship, complete, total participation. Then we take the primary key, that key attribute. Okay, sorry, that primary key we should not call it here. We take the key attribute from the strong entity and add it to the attributes of the weak entity, and we call that composite, complete composite attribute as this key for that particular weak entity. Got it? Therefore, weak entity participation in identifying relationship is total, and in every total relationship, total participation doesn't say that the entity is weak. Got it? So this is how the weak entities are going to work. Okay.